In this recording, we will continue looking at Chapter 11, working with systems of equations. And specifically, we're going to be looking at solving equations by the method and use of elimination. And so we can use the elimination method when using the substitution method gets just messy by trying to, if we don't have an x and a y to substitute, and because we'll be forced to use fractions if we're trying to get the x or the y. So I mean, it's still possible, but elimination is also another method that can be useful. So let's go ahead and look if we have this system of equations, and we're going to eliminate either the x or the y. And so in doing this, you can see that the 3y and negative 3y would be eliminated, basically a net sum of 0, if we were to add those together. So let's go ahead and do that, and we're just going to add those together. We're going to get 6x equals 12. Let's solve for x. Get that off there, and x equals 2. So now if we do that and we say, okay, well now we know x equals 2, let's take and put that back into this formula up here, or excuse me, these systems of equations up here, and see if we can't get y also. So I'm going to go ahead and put this down here so we can move the page. Okay, so I'm going to say x equals 2. Okay, let's go ahead and plug it into 2x plus 3y equals 7, saying x equals 2 and plus 3y equals 7, so we'll have 4 plus 3y equals 7. Get rid of the 4 on this side, and we're going to have 3y equals 3. Getting the y by itself, we'll say y equals 1. Okay, so if that's the case, and that's what we have is y equals 1, I can get rid of this so I can extend the page. Then, and we already said that x equals 2, let's go ahead and test this by putting it into these formulas, and we'll check both of them. Or excuse me, we'll check the one that we just didn't solve. So we'll use this one right here as our check. And so we'll say 4x minus 3y equals 5. So let's substitute in. 4 times 2 minus 3 times 1 equals 5. And that would be 8 minus 3 equals 5. 5 equals 5. And that is our check. And so our answer then for that system of equations is 2 and 1. That's our coordinate, 2 and 1. All right, let's go ahead then, and we're going to do this a little bit differently. We're going to use the multiplication along with the elimination method. And just remember, the key to this is just what you do to one side or what you do to one equation, you have to do to the other. And then we're just going to go ahead and solve it. So let's look at this and say, all right, I can't eliminate anything in here by adding them together, but if I multiply a negative 1 times this equation, then I can get, let's go ahead and do that. We'll apply that. Negative x minus y equals negative 7. Now we're going to bring this one over here so that we can see what we've got. 3x plus y equals 17. Well, now we can get rid of the y's, and we'll just go ahead and add this together, and we'll have 2x equals 10, and get that x by itself. X equals 5. Now we say that x equals 5. We'll go ahead and put this back into the equation that we didn't just solve, so we just solved for the 3x. So let's go ahead and get the other equation, x plus y equals 7, and we'll use the x equals 5 over here. And so we'll say 5 plus y equals 7. get that y by itself. Y equals 2, and so we have coordinates of 5, 2, and let's do a check on that and make sure. So we'll go back to the problem that we originally started with up here, and we'll use that as our check. And so 3x plus y equals 17. And using 5, 2, which is the coordinates that we solved for, and we'll go 3 times 5 plus y, which is 2, equals 17, and that's 15 plus 2 is 17. 17 equals 17, and that checks out. So there you go. So now you might end up with something that is even a little bit more difficult when you look at it. So not just multiplying a -1. And if you'd like to, go ahead and stop the video and try to solve this one on your own. Okay, so moving along, and in this case, what we're going to do is we're going to go ahead and solve for one of these and say, okay, which one can we eliminate? Sometimes you actually have to multiply both of them to be able to get a common denominator. In this case, we can go ahead and get away with just multiplying this by the second one by 2, and so with that we're going to have 6x minus 4y equals 14. Remember, you have to multiply all the way across. What you do to one equation, you have to do to the other. And we're multiplying, well, not do to the other, but you have to do all the way evenly on both sides of the equal sign. Okay, so with that, we have 7x plus 4y equals 25. So now we can go ahead and recognize that when we add these, that eliminates the y. We get 13x equals 39, and get that by itself, and x equals 3. So now that we have our x, let's go ahead and solve for y, and we'll do that in the problem that we originally had, this first one up here, and so we'll plug that back into 7x plus 4y, because we didn't just solve for that one, we used the one below it to solve, and we will plug x is 3 into that x plus 4y equals 25. We end up with 21 plus 4y equals, 25. Get rid of that 21. Equals 4, and y equals 1, and so we have our coordinates in our answer. Our pair is 3, 1, and so let's go ahead and apply a check to that, and we'll use the one that we have here. So we'll go 3x minus 2y equals 7, and so applying the x, we have 3 times 3 minus 2 times 1 equals 7, and that's 6 minus 2, and I went astray somewhere. 3 times x is, how about, let's try this again. 3 times 3 is 9 all day, minus 2 equals 7. Sorry, I got ahead of myself and was looking at the next slide. 7 equals 7, and so that checks out. All right, excellent. And that is the end of this video, so we will be moving on.